When we're given a graph, it's fairly simple to identify the extrema. The question is asked then, how the heck do we find the extrema when we don't have a graph given to us? Well, that's when critical points come into play. Definition of a critical point is just f is defined at c, then f primed of c is 0, or f primed is undefined at c, then c is what we call a critical point of f. The relative extrema only occur at critical points. If f has a relative minimum or a relative maximum at x equals c, then c is a critical number of f. The converse of this, though, is not necessarily true. Alright, so all that we need to do is look at the previous example to see that. Well, if I was to take the derivative of this, just looking at c through e, if I was to take the derivative at c, I would see that my slope at c is 0. My slope at d would also be 0. And my slope at e, well, that's a pointy place, meaning I can't take the derivative of that, which would make the derivative of e undefined. Alright, so just because the derivative is equal to 0 or undefined does not mean that there is a relative or minimum or maximum there. Relative extrema can only occur at the critical points, and the critical points occur only when the derivative is either 0 or undefined. However, it is possible for the derivative to equal 0 or be undefined, and there be no extrema there. Alright, if you need to convince yourself of this, try f of x is equal to x cubed, and f of x is equal to the cube root of x at x equals 0. So, is the derivative 0 undefined? Is there a maximum or minimum? Not really. So, guidelines for finding the absolute relative extrema on a closed interval. We find the critical numbers of f of n a to b by what? We have to take the derivative. And setting that equal to hopefully 0 or seeing where it's undefined. So f prime has to be 0 or f prime has to be undefined. These critical numbers and the endpoints make that list of candidates for extrema. Then we just need to evaluate each candidate by plugging these numbers into the original function. Alright? Besides taking the derivative, honestly, that's the worst part, because you could get like 6 numbers that you have to plug in and try. Alright, but it's still just plugging in numbers, and guess what? Most of the time we've got calculators. Alright, the least of these values from step 2 is the absolute minimum, and the greatest of these values is the absolute maximum. If the interval is closed and the endpoints do not result in an absolute max or min, a side chart can be used to determine whether or not the endpoints result in a relative max or min. Alright.